As you can see, today we are gonna learn how to make a simulation of a mechanism, in this case of a piston crankshaft and connecting rod mechanism. Okay, let's start. We're gonna start with mechanical design, assembly design. So now we have our product file. We can rename it going to the heading and right click, properties, and we can name it as we want. Okay, for this example, I already done all the parts involved in this mechanism, so I don't have to create any part. So I just need to go to the assembly tree and go into components and existing component. Now we have all my parts here that I previously already done. So the first one is gonna be the connecting rod, open. Second one, same procedure, cylinder, open. So make sure that when you do this operation, always place your cursor on the heading of the tree. Component, existing component. Part 2, that actually is the crankshaft. Same procedure for the next one, piston. And finally, this part that I call reference. Now that we have all our parts inside our graphic area. Today we are going to learn to use three main tools. The first one is going to be manipulation, second one is going to be fixed component, and the third one is going to be coincident constraint. Okay, let's start with the first one. This is for moving our parts in any degree of freedom. As you can see, we have the option of move along an axis, along a plane, and around an axis. So now I'm gonna use this drag along x-axis in order to separate all these parts and to have a general view. I just need to drag it, as you can see. Okay, now we can see my 1, 2, 3, 4, 5 parts. Okay, next tool that we are gonna see today is fixed component. So I just need to click on it and select the part that I want to fix. And with this option, I fix out the degrees of freedom for that part. Next one, and that is very useful, coincident constraint. With this tool, we can make coincident axes, planes, faces, and axis with planes. Okay, so click on it, and I'm gonna make coincident the axis of the piston with the axis of the cylinder. I just need to click on the cylindrical face of the piston, and automatically the software detects the axis. Same procedure for the internal cylindrical face of the cylinder, and the symbols are little circles that now they are in gray. So I just need to click on update icon, and the symbols change into green. That indicates that the constraint is activated. I'm going to use again my manipulation tool. When I use drag along any axis, I'm going to select the axis of the piston, and I'm going to move the piston itself in order the piston goes inside the cylinder, right there. Same procedure for the connecting rod. I'm going to select the cylindrical face of that hole and the internal cylindrical face of this hole. Update, and now the axes are aligned. But the connecting rod is not at the right height, so I will use the same tool, but now I'm gonna use it to make coincident planes. In this case, the symmetrical planes of the conductive rod, that is this one, with the symmetrical plane of the piston, that is this one. We have several options for doing this coincidence on defining same and opposite. The main options are same and opposite. For this case, it doesn't matter which option we select. I will explain you the difference between them in a while. I'm gonna use opposite for this one. Just click on update, and now the connecting rod is at the right position. So I just need to rotate it a little bit. I'm going to use drag around any axis. I'm going to select this axis, and I just need to drag it around that axis. Okay. Next step, I'm gonna make coincident this axis with this axis. So click on the cylindrical face of the balls of the crankshaft and click on the internal cylindrical face of this hull of the connecting rod. Update. And now the axes are coincident. So I will make coincidence now. Faces. This face with this face. And now here is where it is important to select the right option, opposite or same. In this case is opposite because it refers that I want that both the normals of those two faces are pointing one against the other one. If I would select same, I will tell him that I want that the normals point to the same direction, and I'm gonna do it in order you to see. I'm going to click on update, and you can see when I selected the option same, this is what happens. The faces are coincident, but the normal are pointing to the same direction, and that is not what we want. So I'm gonna do a Control Z, and I'm gonna do it in the right way. I select this and this one, opposite. Update and OK. That's what I want. Next step, I'm gonna use my manipulation tool. I'm gonna select the rotation around any axis. I'm gonna select this axis, and I'm gonna drag the crankshaft a little bit. Okay. Now I'm gonna make coincident the axis of the crankshaft with this normal plane of the piston. This with this, and click on update. And now the axis is coincident with the plane of the piston and the cylinder. Next step, sorry about that. I will make coincident the axis of the reference part with the axis of the crankshaft. Okay. Now I will fix this reference part. You can see the symbol. Okay. Now my mechanism, my assembly is completely constrained in order to make the simulation that I want. So I just need to click on here, and using the same option, drag around at any axis. I'm going to select the axis of the reference part, and I just need to drag the crankshaft around that axis. Can you see? Well, a little issue here because when the piston is on the bottom, that that point, it goes out from the cylinder. So what I have to do here is to delete that constraint temporarily, use my manipulation tool, move it along the axis of the piston downward, okay, and fix it again. And repeat the operation of rotating the crankshaft around the reference part. And well, voila, we have our animation. Okay, I hope this has been useful for you. Thanks for watching. If any comment, if any doubt, please leave it below. And